Hello and welcome to session 4 on decimal numbers. By now you should have completed session 1, 2 and 3, ready to move on to session 4. Let's start as always with our maths meeting. We've got 3 squared, 4.2 times 100. Now remember, when you're timesing by 100 you're moving the number up the place value grid. My easy way of doing this, I always think about this as the ones is the 4 there. So when you times 4 by 100, where should that be on your final answer? And to use it as a check when you've found your answer. Then we've got a column addition. Both numbers have 2 decimal places, line them up carefully. Then we have a 5-digit number, subtract a 4-digit number, again column subtraction. And finally, short division, 426 divided by 3. Pause the video, work them out. And let's look at the answers in 3, 2, 1. Give your answers a tick. For this third one, if you have written 107.00, it's absolutely fine, it's still correct. Okay, let's check the answers from yesterday's lesson. This represents 1 whole, there's your 2/10 and 3/100. 1.23. And one of the ways you can write it as a fraction is 1 and 23/100. And then we've got 2 wholes, and 1, 2, 3, 4, 5/10 and 1, 2, 3, 4, 5/100. 2.55. Again, we have 2 wholes, and then 1, 2, 3, 4, 5, 6, 7/10, 2.7. And with our fraction, we can write it as a tenth because there aren't any hundredths, so we can keep it as simple as possible. Okay, the large grid that we were given. Pause your screen for a moment, you can mark correctly. Okay, well done if you got all of those correct. Keep working if you didn't. Let's have a recap of session 1. Session 1, we were recognising numbers with 2 decimal places. So can you complete my STEM sentences? There are how many ones, how many tenths, how many hundredths, and can you tell me what the number is that's represented on this place value grid? Okay, let's work it out together. There are 1, 2, 3, 4 ones. There are 1, 2, 3, 4, 5, 6 tenths. And there are 1, 2, 3 hundredths. So I know there are 4 ones, 4 ones, 6 tenths, and 3 hundredths. The number is 4.63. Okay, in session 2, we were recognising the value of digits in decimal numbers. So can you tell me what the value of the digit 9 is in this number? 0.794. What does that 9 stand for? Think about your place value grid, you've got your ones, and what are each of these? What does that show you? Work it out, write it down. And let's look together in 3, 2, 1. It's 0.09 or 9 hundredths. I grab my little pen. I can remember this is the ones column, this is the tenths column, and this would be the 100ths column. And this 4 would be in the thousandth column. Okay, what about then partitioning 4.03? Partitioning or expanding it, what do you add together to make 4.03? Take a moment to write it down. Okay, and let's look together. It's 4 for whole ones and 0.03. There are no tenths to add in here. If you did write in 4 plus 0.0 plus 0.03, absolutely fine. Doesn't matter, but that 0 means nothing. There is no value to it. So you don't need to write it. No problem if you have though. Okay, this was yesterday's session. This is session 3. Can we compare fractions and decimals? So if I've given you the fraction 3 wholes and 45 hundredths, how would you write that? And if I gave you the decimal 0.5, how many different ways can you write that? They all mean exactly the same thing. They all have the same value. But how many ways can you write it? Pause the video and have a go. Okay, let's look together. 3 wholes and 45 hundredths is the same as 3.45, or 3 plus 0.4 plus 0.05. 3 add 4 tenths add 5 tenths, or 3 ones, 4 tenths and 5 hundredths. And 0.5 is the same as nothing add 0.5. You can't expand it any further. It's the same as 50 hundredths. Could change it to 5 tenths, but there's no way you can expand it further, and it is 5 tenths. I've also written that it is a half, because if you imagine one of our large grids of 100 squares, and you coloured in 50 of them, you have actually coloured in a half. So if you ever have a number, something 0.5, you know it's something and a half. So 2.5 would be 2.5. 300.5 would be 300 and a half. The 0.5 always indicates a half. And if you remember from yesterday's session, 0.25 always represents a quarter. So if a number is 1.25, it's always 1 1/4. Or if it's 3.25, it's 3 1/4. And that's some of the ones that you're going to need to learn to remember. We'll go through those in more detail. Okay, on to today's lesson. Today we're going to compare and order numbers with decimals. So I just wanted to remind you of this drawing that we had a couple of sessions ago. We represented the thousands, hundreds, tens, and then we had a small dot for the ones, but we put over a magnifying glass. Now, a magnifying glass made our 1 into a large cube rather than just being a tiny cube. And we split it into 10 equal pieces, which made our tenths. We split that into 10 equal pieces, which made our hundredths, and we split that into 10 equal pieces that made our thousandths. And by using this magnifying glass over it, you can see that there are 10 thousandths in a hundredth, there are 10 of these hundredths in a tenth, and there are 10 of these tenths in a whole one. It's just a visual representation to help you to understand the decimal system. Remember the decimal being 10, and to hopefully help you to understand the size of each of these parts. The thousandth being very, very small. It goes in sort of opposite direction in this way. They get bigger and bigger and bigger, and thousands are bigger, but thousandths are smaller because it's split into small pieces, split into far more pieces. Okay, take a moment to have a look at that. Fix that in your mind. Each time they're getting 10 times smaller. They're being split up into 10 equal pieces. Okay, so we're going to start comparing and ordering some numbers with decimals. First of all, we're being asked to circle the largest amount. We've got 0.1 or 0.01. Now if we think about it, our 0.1s, large square like that. That was what our tenths looked like, wasn't it? Whereas our hundredths had been split again into one of the rods. So which one is the largest amount? Well, a tenth is larger than a hundredth. So a hundredth has been split into 100 equal pieces, where a tenth has only been split into 10 equal pieces. Okay, so circle the largest amount, 9 or 0.9. we remember our drawings, this is going to be quite tricky to draw on my computer. We made our whole number into a cube, didn't we? And there'd be 9 of those cubes to make one whole. And 0.9, there would be 9 of these. So which are there going to be more? If there's 9 of these or 9 of these, the largest amount will be 9 whole ones. Okay, which is bigger, 0.5 or 0.23? Look at those numbers, and this one you've got 5/10, and yet this one you've got 2/10, but you've also got 3/100. So which is smaller? There's a couple of ways of looking at this. First of all, we could think about a 0.5. We think of our visual representation, that's 5/10. 1, 2, they're getting scruffier, keep them neat. 3, 4, what are we using for tenths? Or 0.23, I would have 2 of those tenths and 3 of those rods. So which one is bigger? You can see by the drawing there which is bigger. Another way of looking at it is this 0.5 has got no hundredths. It's got none. So which is bigger? 0.50 or 0.23? Let's think of them as money if you like. This was 50p and this was 23p. Which is bigger? Again, you can probably tell which is bigger from that. It is the 0.5. Now it's up to you how you think of this. For some of you, the drawings might be helping. For some of you, just realising that the further to the left they are on the place value grid, the larger they are. Millions, when we looked at those, were furthest to the left and they were the largest because each time they split into 10 smaller pieces as you go towards the right on the place value grid. So if that's what helps you, that's fine. If drawing them out helps you, that's also fine. If thinking of them as money helps you, that's fine. Any of these could have been thought of as money. This one could have been 10p. This one could have just been £9, whereas this one would have been 90p. Whatever way round you think of it is fine. Let's have a look at our second piece of work today. Insert the correct symbol. Greater than, equals to, or smaller than. We've got 4.5 and 4.05. Okay, they both have the same number of ones. This has 5/10, this has no tenths, this has no hundredths, and this has 5/100. I'm going to put the 0 in to show it has no hundredths. Take a moment, you can draw it out if you want to, or you could think of it as money. Which symbol should go into there? I would insert this symbol. £4.50 is more than £4 and 5p, and 5/10 are definitely bigger than 5/100. Okay, so we've got 0.003 and 0.007. So working with thousandths here, these we got down to our tiny dots, didn't we? So we've got thousandths here. They would literally be our little 1, 2, 3 little dots, or 1, 2, 3, 4, 5, 6, 7. So you can see which is bigger, 3 thousandths or 7 thousandths. There are more in the 7 thousandths. You can think of it as money if you think that money goes further than just pennies, because in bank accounts, if you have interest in things, you can have points of pennies as well. But for this one, perhaps the drawings help a little bit more. This is why we look at different ways of working these out, so you've got different representations in your mind to work them out. Next one, 0.3 or 0.30? Some of you probably thought I've made a mistake here, while others have gone and looked at it and thought that's a bit, they look a bit odd. There's something strange about them. Well, this one has 3/10, and this one has 3/10 and no hundredths. We could say that this one has 3/10 and no hundredths. They are exactly the same. So even though they were written very slightly differently, they actually have the same value. Okay, this time we're going to order from smallest to largest. Very important to make sure we're ordering in the right direction. And here we've got some numbers. So how are we going to tackle this to begin with? I would start by giving them all the same number of decimal places. They now all have 2 decimal places. Sorry, that 0 is a little bit wonky there. But now they've all got the same number of decimal places, we can look at them as money. We've got 40 pence, 45 pence, 54 pence and 50 pence. Well, if it's 5 in the tenths, it's going to be bigger than these 4s in the tenths. So one of these is the smallest. Which one? 4 tenths and 0 hundredths, 4 tenths and 5 hundredths. I know that if it's got 0 hundredths, it's going to be smaller than if it's got 5 hundredths there. So it's going to be 0.40, then 0.45. Then we can compare these ones to see which one is next smallest and which one will become the largest. We've got 0.54 and 0.50. They both got 5 tenths, but this one has more hundredths. So 0.5 will come next and 0.54 will be the largest. Again, doesn't matter if I've left the zeros on these. It just means there is nothing in that place. And the next one, we're going to order from the largest to the smallest. Here are our numbers. All have 3 decimal places. So we want to look for the largest, so we need to have the largest number in the tenths. 1, 0, 9, 8. So the largest in the tenths is going to be this one. We can carry on looking in that tenths column. It's got the most tenths, and they've got 1 tenth, no tenths, and 8 tenths. Well, I know that 8 tenths is going to become next. And we've got 1 tenth and 0 tenths. 1 tenth is going to be more than 0 tenths. So just by looking at the tenths, I didn't even look at the hundredths and thousandths columns. I know that 0.9 something is going to be larger than 0.8 something, which will be larger than 0.1 something, and then I know the smallest will be 0.0 something. And there they are. Okay, this time we're going back from the smallest to the largest on the wiggliest line. This time we've got a number with 1 decimal place, 3 decimal places, 2 decimal places and 3 decimal places. I'm going to even it up first of all by making them all have 3 decimal places. There they are, they all have 3 decimal places. I'm going to stop talking just for a moment and I'm going to let you have a think about how you would order these from smallest to largest. The first thing I would do is look at the tenths column. This has 1, this has 0, this has 9, and this one also has 0. So the smallest are the ones that are going to have no tenths. And there's 2 numbers with no tenths, so we're going to have to look a little bit deeper. Let's look at the hundredths. This also has no hundredths, whereas this one has 9 hundredths. So the smallest is going to be this one. Then it'll be this one. And then I need to look at these 2. So which is smallest between these 2? This was 0.1, 1 tenth, where this has 9/10. So 1/10 will be smaller than 9/10, so the largest number is this one at the end here. Well done if you got that correct. Okay, here's yours to have a go at. There's this page and there's another set after this. So we're ordering these ones smallest to largest. Another set smallest to largest. But look out because these ones are largest to smallest and these ones are largest to smallest. Pause the video and have a go at working these out. Okay, let's look at the next page. This time these ones are smallest to largest, largest to smallest, smallest to largest, and then largest to smallest. Be careful not to get tricked by those. And some of these have different numbers of decimal places, so don't forget that you can turn them all into the same number of decimal places by putting some zeros on the end. Once you have completed this, take pictures of your work and put them onto Class Dojos to earn today's dojos. And I will see you next session.